Hi guys, this is lecture 8.2, Equations of Planes. Suppose we have the equation x plus 2y minus 8 equals 0, defined in a 2-space. This line will pass through several points including A, B, C, D, and E that's written on the slide. The same equation can be graphed in a 3-space. But in a 3-space, there will be a third coordinate, which is z. And each point will have a z coordinate associated with it. So instead of saying 0, 4 as a point that the line passes through, we say 0, 4, z, where z can be a value which will satisfy the equation. Plotting sets of these points on isometric graph paper suggests a surface that is parallel to the z-axis and contains a line x plus 2y minus 8 equals 0. This surface is a plane. In general, the scalar equation of a plane in 3-space is ax plus by plus cz plus d equals 0. Let's take a look at example 1 from the learning resources. Consider the plane defined by the scalar equation x plus 2y minus z minus 8 equals 0. Determine if the point A, which is 1, 3, negative 1, is on the plane. Determine the x, y, and z intercepts of the plane. Determine the coordinate of another point on the plane. Let's take a look at question A. To test if a point is on the plane, its coordinate must satisfy the equation. What we have to do is check the left side and the right side and see if they're equal. For the left side, we had x plus 2y minus z minus 8. X will be equal to 1, y equals to 3, and z equals to negative 1. When we plug in that equation, we get left side equals 0, which is equal to the right side. Therefore, point A is on the plane. To find the intercept in 3-space, set other coordinate equal to 0. At the x-intercept, we have y and z all equaling to 0, so we have x equals to 8. At the y-intercept, we have x and z equal to 0, so y equals to 4. And last, at the z-intercept, we have x and y equaling to 0, and z equals to negative 8. For question C, to find the coordinate of another point on the plane, choose arbitrary value for 2 of the variables and solve for the third. Let x and y both equal to 1. If that happens, we get z is equal to negative 5. Therefore, 1, 1, negative 5 is a point on the plane. Let's take a look at vector equation of a plane in 3-space. We have r is equal to r naught plus ta plus sb. Or xyz is equal to x naught, y naught, z naught plus t of a1, a2, a3 plus s of b1, b2, b3. Where r equals to xyz is the position vector for any point on the plane. R naught is a position vector for a known point on the plane. A and B are non-parallel direction vectors parallel to the plane, and T and S are scalars. Parametric equations for a plane in 3-space. We have x is equal to x plus ta1 plus sb1. Y is equal to 1 plus ta2 plus sb2. And z is equal to z plus ta3 plus sb3. There's actually a mistake on the slide, and right hand side, instead of x, y, z, it should be x naught, y naught, and z naught. And that's the end of this lecture. Thank you guys for watching, and I'll see you guys next time.